Alright, so we're talking about the derivative and the tangent line. So Calculus AB has three main topics: limits, which we've covered pretty much, derivatives, and integrals. So limits, we've gone over that. Now we're going to start derivatives. So one way to find the tangent to a general curve, at the end of the other notes we talked about a tangent to a circle. That's a special case, but any curve can have a tangent line to it. The difference is a tangent line can hit a curve in more than one place. On a circle it's only once. So one way to approximate a tangent line is the slope of a tangent line is to look at a secant line. So approximate the slope. So if we graph this, that's a parabola shifted up 3. So that would be here. The scale is going by halves. So the bigger lines, that's 1, 2, 3, 4. So normal parabola is at 0, 0, plus 3, it's shifted up 3. Then we go over 1, up 1, and over 1, up 1, 2, 3. Or you could plug in values if you wanted to. Now parabolas have symmetry, even symmetry, so we can reflect these points over the axis. 4. Alright, so if we graph that, now if we want to find the slope of the parabola at this point. Yes, parabolas have slopes also. So we're looking for the slope of the tangent line right here. So that tangent line would look something like this at 1, 4. So that's the tangent line. So the secant line is going to be, we would use 2 points that we have near it here. So we would use these 2 points. So the 2 points that passed through were 0, 3, and this point up here, which was 2, 7. So if we calculate the slope between those 2 points, that would be 7 minus 3, y minus y over x minus x. So that would be 4 over 2. So the answer to that question would be 2, if we approximated the slope. Now if we wanted the equation of that tangent line, that is similar to the tangent to the circle we did in the last notes. So again, we would want point slope form. So that's going to be y minus y and the slope times x minus x. So that would be the equation of the tangent line. So we want to get in the habit of, as soon as they say equation of a tangent line through a point, we write point slope form down immediately. Okay? So the secant line is not related to the secant trig function. So that's all that's saying on the side. Okay, so what we're looking at here and how this connects to calculus and what we studied in chapter 1 is that, so here we have the parabola and here we have a secant line. And what we're wondering is, what's the slope of the tangent line down here? So what we do is we take this point and we start moving it closer and closer to the actual point of tangency. So that same concept that we just used up there using the secant line to approximate a slope, except now one of the points of the secant line is the point of tangency. Now you see up here that wouldn't have been a good approximation because I would have went from here to here and that would have been steeper. But we're going to do it here because we're going to take that point and move it closer, and you can see as we move the point closer, the slope flattened out. And we're going to move it all the way down, and we're going to take the limit as the distance between those 2 points approaches 0. So delta x is the distance between the x distance between those 2 points. So the secant line is the change in y over the change in x. That's right here. So that's the y coordinate, and that's the x coordinate. So we're going to take the limit of this, which is the slope. That's the y coordinate at c plus delta x, and that's the y coordinate at c. And delta x is what we get when we subtract those two things. The c's cancel. Okay, so we need to memorize that. Okay, that's called the difference quotient, which is when we divide two things that are being subtracted. Okay, so the smaller delta x becomes there, then the closer the slope will match. So that's why we're taking the limit as delta x approaches 0. Okay, so find the slope of the tangent line to the graph of f of x at 310. So we're taking the limit as delta x approaches 0 of f. Well, actually, I'm just going to plug it in. So the function is 3x plus 1. So here we're plugging this into the function, except we're going to use x instead of c. So it's going to be 3 times x plus delta x plus 1. So that's that. Minus f of x. So f of x is right there. So minus 3x plus 1 over delta x. Okay? So when we do this, mostly we're going to do x plus delta x and x instead. Okay? So if we simplify that numerator, if we distribute there, that's going to be 3x plus 3 delta x plus 1. And distribute here, that's going to be minus 3x minus 1. All that's going to be over delta x. So the 3x's cancel, and the 1's cancel, and we're just left with 3 delta x over delta x. The delta x's cancel, so we're just left with 3. So we have the limit as delta x approaches 0 of 3. Well, there is no delta x, so that's not really, so it's just 3. So the slope is 3. In this process that we're going to do on this assignment, stuff's going to cancel. Stuff's going to cancel a lot. And this always needs to cancel out with something from the numerator. If it doesn't, you did something wrong. Okay? So, there's a couple things going on here. Now, when you see a problem and it says find the equation of the tangent line, I want you to immediately start writing down point-slope form. So that's going to be y minus 8 equals x plus 2. Y minus y equals the slope times x minus x. So I want you to do that immediately when you see that in a question. This automatically goes to this. Okay. Now, to find the formula for the slope, which, by the way, let's go back here for a second. So what they asked us for was the slope of the tangent line to the graph. But the tangent line to a line is just the line. A line is this line is changing by 3. The slope is 3. So when you do this process on a line, you should just get the slope of that line, because the slope of the line is the slope of the tangent line. It's kind of a weird case. Anyway, so down here. So we're using the formula. So we have the limit. You need to memorize this formula. So if you want to, you could pause right now and you could go back up here and you could memorize kind of what's happening in this formula right here. And then you want to try and do it from your memory, not looking up there. So the first thing I'm supposed to do is I'm supposed to replace the x's with x plus delta x's. So that's going to be x plus delta x squared plus 2 times x plus delta x. Alright? And then, just like the last problem, we're supposed to subtract the function. So that's going to be x squared plus 2x. And that's all over delta x. Okay? Okay, so now we're going to expand all this stuff and a bunch of stuff should cancel. So this is going to be x squared plus, and if we FOILed this out, we get x times delta x plus x times delta x. That's 2x. Now you got to be careful here. I think I saw in an assignment somebody multiplied these x's together to get x squared. You can't do that. These are different. This is delta x is one thing. That's one thing. That's not delta times x. Delta x is its own variable. So don't try to combine those x's. And then here you're going to have plus delta x squared, but it's the whole thing, delta x squared, like that. Now you're going to subtract and distribute, so you're going to get minus x squared minus 2x. And all that's over delta x. So stuff should cancel. That's what it says in the margin. That cancels, that cancels. Oh, wait a second. And I forgot to, I left off this part. I just expanded that, and then I jumped over here and I skipped this part here. So I'm not going to be able to squeeze that in very easily. This should be right after that. So I'm going to put it over here. So that's going to be 2x plus 2 delta x plus. Okay? So I skipped over that step right there. This expands to this distributes to this, and then minus distribute that negative there. So this 2x is going to cancel out that negative 2x. So now let's group this back up so it looks a little better. So that's 2x times delta x plus delta x squared, and then we would have had plus 2 delta x over delta x. Okay? Now, we can factor out a delta x out of all three of those things. So that's going to give us delta x times 2x plus delta x plus 2 all over delta x. So there are three terms here, and all of them have a delta x in them, so I can factor that out. Okay? So, now that delta x will cancel. We said earlier that that delta x should always cancel out. Now we're taking the limit as delta x approaches 0. So that means that this is going to approach 0. That's just going to leave us with 2x plus 2. So that's the formula for the slope of the tangent line. Now we can use that formula to find our slope. So that says the slope is equal to 2 times x plus 2. So 2 times negative 2 would be negative 4, plus 2 would be negative 2. Okay. To find the slope of the tangent line is called the derivative. And specifically, this is called the limit definition of the derivative. And we need to memorize the format of this. We will see this, and it'll be, and some students will think, oh, I need to take the limit of that, when in fact you just need to realize that that's a derivative. And I'll show you what I mean later. So memorize this. Here's the symbol. It's f prime of x. F prime of x means this, as long as the limit exists. F prime is also a function of x. The derivative is used to find the slope of the tangent line. There are many different formats for a derivative. Y prime, dy dx. Those are the main two that we'll use, y prime and dy dx. Okay, so this is a fairly typical AP exam question. It's on almost every single one. It was on the one we just took over the last year, the ones that students took from home. This question, or a question very similar to this, was on there. So it says, let the f be a function that's differentiable. That means you can take the derivative of it, which is this process we're about to do for all real numbers. The table below gives selected values. Estimate f prime of 4. So what they're asking us to do is approximate the derivative at 4. The slope of the tangent line, derivatives are the slopes of the tangent line at 4. Well, 4 is not on the chart here, but we can do a secant line. So 4 would be right in between those two. So if we calculate the slope in between those 2 points, then we get our answer. Now, so if we calculate that slope, that's going to be y minus y. So that's going to be 4 minus a negative 2 over 3 minus 5. Now,